The product rule for integrals or integration by parts can be used to try to figure out the integral of cotangent inverse. Why? Well, because integration by parts has some derivative function in it. So we can say let v equal cotangent inverse and take that derivative, because we know the derivative of cotangent inverse, we figured that out. It is -1 divided by 1 plus x squared, like this. So trying to find other pieces of this formula, we can say let the du equal 1, because remember we're trying to integrate integral of cotangent inverse, so we can say 1 times cotangent inverse, like this v du. And of course we can solve for u by integrating both sides of this equation. So the integral of du is u, the integral of 1 dx is x. So we figured out what u is, it's equal to x. Now we can plug everything into the formula. So doing so, well, the integral of v du, so that's the integral of cotangent inverse of x times the dx. So that was the du, it's equal to dx, that's why it goes here. Now we just need the u and v, so cotangent inverse of x, that is the v, and the u is x, so that's right here. The u is x, cotangent inverse of x is v, minus the integral of v dv. So minus the integral of x, because that was u, and then dv, we solved for it. It's -1 divided by 1 plus x squared dx, right here. So now we can use another substitution. We can say let w equal 1 plus x squared, and then we can solve for dx. So taking the derivative of this side, we get 2x. So we get that 2x dx is equal to w. Now we can solve for dx by dividing both sides of this equation by 2x. And now we solve for dx, and we can plug it in here. So doing so, of course, this is the same part, x cotangent inverse of x. But notice the negative and negative become positive. And now we can plug everything in. So the x stays the same. We said let 1 plus x squared equal w. And of course, the dx was 1 over 2x dw. So we plugged it in. Notice the x's cancel now, and we just get integral of 1 over w. The integral of 1 over w is ln absolute value of w, like this. And of course, the 1/2, we can factor it out. So our final answer, the integral of cotangent inverse of x is equal to x times cotangent inverse of x plus the 1/2 ln of w, which was 1 plus x squared, and of course plus c. So the final result, the integral of cotangent inverse of x is equal to x times cotangent inverse of x plus 1/2 ln of 1 plus x squared.